Hello, my name is Ardi and we are going to solve practice problem 3.5 from Sadiku book. So the question is calculate the mesh currents I1 and I2 in the circuit of figure 3.19. So here is the figure and we already given the loops here. This loop is loop I1 and this loop here is loop I2. So we need to do KVL on I1 here and then also on I2 here. Let's do that. Let's do KVL at loop I1. KVL at loop I1. And what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. Okay, now the current is flowing from the negative terminal to the positive terminal. So we will have negative sign and then the magnitude is 45. Good. And now let's move on to this component here. We have 2 ohm resistor here. And then the only current that pass through it is I1. So we multiply it by I1 because the resistance multiplied by current is voltage, right? And now let's move on to this component here. But this time we have 2 currents. I1 is flowing down, I2 is flowing up. So let's write that 12 resistance first. And because currently we are working on I1, we write I1 first. So we will have I1 here. And here I2 is flowing to the opposite direction of I1. So I subtract I2 from it. So we'll have minus I2. Good. And now for the last component, we will have this 4 ohm resistor. So we'll have plus 4 I2. All of that will equal to 0. Good. Oh no, this is for I1. The only current that pass through it is I1. Okay, that is good. Now, what can we do from here? We have I1 here, 2I1 plus 12I1. So I will have 14I1. Then 14 plus 4, that will be 18I1. So we'll have 18I1 here. And then I2 only comes from this term. So we will have minus I2 multiplied by 12. So we will have minus 12I2. And for the rest, maybe let's move this minus 45 to the right-hand side. So we will have 45. Okay. And now we have one equation, but with 2 variables. We need one more equation. Maybe let's just save this as equation number 1. So let's move on to another KVL, but this time at loop I2. Okay, and KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's start from this 12 ohm resistor. So we'll have 12, but we need to multiply it by the current. And remember, we are working on I2 here. So we will have 12 multiplied by I2 first. But here I1 is flowing to the opposite direction. So we will have minus. Good. Now we will have plus this component here. I will have 9 multiplied by I2 because that is the only current that passed through it. And then we will have 30 volt, but the current is flowing from the positive terminal to the negative terminal. So our sign will be positive and we will have 30 volt here. And for the last component here, that will be this 3 ohm resistor. So we'll have plus 3 and then multiplied by I2. And all of that will equal to 0. Good. Now let's do some simplification here. Okay, the term I1 only comes from this one, and that is minus 12I1, right? So we'll have minus 12I1. And then for I2, there comes from 3 terms here. This one, 12 plus 9, that is 21. 21 plus 3, that is 24. So we'll have plus 24I2. Okay, that is good. And then the constant term only comes from here, and that will be minus 30, right? And let's save this as equation number Okay, we have two equations with two variables. Maybe we can just use elimination here. And because this one here have minus 12 and this one here have 24, I think we can eliminate I2, right? So the equation 1 multiplied by 2. Okay, so we will have 18 multiplied by 2, that will be 36 I1, and then minus 24 I2, and then that will equal to 90, right? We multiply both sides by 2. And then the second equation, I don't need to multiply by anything, or it's multiplied by 1. So we will have this equation here. We have minus 12 of I1, and then plus 24 of I2, and all of that will equal to minus 30. We can add them up. So we'll have 24 I1 here is equal to 60. Or we can divide both sides by 24. So I1 is equal to 60 divided by 24. We can divide both numerator and denominator by 12. So we will have 5 over 2. Or we can rewrite this as I1 is equal to 2.5. And the unit is ampere, right? Okay, and this is one of the answer. And I think we are doing good here because this is the same as that one. Okay, so far so good. Now, we need to find out what is I2. So we can just plug this I1 into this equation here. So we will have 18 multiplied by 2.5. Okay, and then minus 12 I2, and then that will equal to 45. Good. 18 multiplied by 2.5, that will be, I think that will be 45. 45 minus 12 I2, that will equal to 45. And let's move this 45 to the left hand side. 45 minus 45, that will equal to 12 I2. And this will be equal to 0, but I put it on the right hand side. And on the left hand side, I switch this. So I will have 12 I2. Therefore, I2 is equal to 0. And the unit will be in ampere. And that is the final answer for this question. So I1 is 2.5 ampere and I2 is 0 ampere. And that is the same as the answer given by the book. So thank you for watching. See you in the next video. Bye bye.